object is dropped, it's giving you a hint. Drop means that the initial velocity is 0 from a height of 64 feet at time t equals 0. And the acceleration, a of t, due to gravity is constant and equals negative 32 feet per second. So I want to find v of t. If I want to know what the velocity is, well, we know it started at 0. We know v of 0 equals 0. And then v of t, what is really making this thing move if I'm dropping it is just acceleration. Or let me say it in a different way, is really just gravity. That's the only thing that's making, if we had no gravity and you dropped an object, it would just stay put, right? It wouldn't move anywhere, but gravity pulls it down. And notice it's in feet per second squared. So if I multiply by time, then I'll get feet per second, which is velocity, like miles per hour. I multiply this by t, and I get the equation for the velocity. What am I finding the derivative of to give velocity? If I start with position and I take the derivative, I get the velocity. Integrals and derivatives are actually inverses of each other. If I know velocity and I want to find the height, then I take the integral. To find the height, it's equal to the integral of v of t, which is equal to the integral of minus 32t dt, which is equal to negative 32 times the integral of t dt. And you can look on your little sheet, and it would be negative 32 times t squared over 2 plus c. No.
Is it times 0?
We're starting at time 0, but we don't have an end time. So I can't just put one number in. I need both numbers or no numbers.
Right.
So here, right, this equals negative 16t squared plus c. What can we do to find c?
You set it to 64.
Exactly. So this is h of t. And I know when t equals 0, h of t equals 64. I can say that 64 is equal to negative 16 times 0 squared plus c. Obviously, that's 0, which makes c equal to 64. So I know h of t is equal to minus 16 t squared plus 64. And now you tell me what t is, I'll tell you where. Now it says find the time at which the object reaches the ground. How would we do that?
You set height to 0.
Exactly, because when it touches the ground, there's no height. I just say 0 equals minus 16 t squared plus 64. 16 t squared to both sides, divide both sides by 16. And I get t squared equals 4, which means t is equal to plus or minus 2. But we never talk about negative time. My final answer is t equals positive 2. The force in a spring stretched x meters from equilibrium, which just means if here is my spring before I pull on it, then I'm going to stretch it, exerting a force on that spring. And it says find the work done in stretching the spring from 1 to 2. Work is equal to force times distance. And force we know is 20x newtons. When I first pull on that spring, it's probably really easy to move it. And the more I pull on it, the harder it gets for some reason. That's because it's not a constant force, which is why we can't just multiply 20 times x times the distance between 1 and 2 is 1, because it's not constant the whole time. The force is changing depending on how much I'm pulling on that spring. So that's why I need to integrate. So I'm going to integrate this from 1 to 2 of 20x, and my distance I'm going to write as dx. Dx means it's a really, really, really tiny piece. Once we set it up, this is pretty easy to do because it just becomes 20 times the integral from 1 to 2 of x dx, which is equal to 20. And the integral of x is x squared over 2. And I'm going to evaluate that between 1 and 2. 20 over 2 is 10 times 2 squared. Let me just do this. 10 times 2 squared minus 1 squared, which is equal to 10 times 4 minus 1, which is 3, or 30. And then it's Newton meters, because newtons is force and meters is distance. An object is moved horizontally by a force, and I guess we're going to find work. There's my force function given as a function of position, x meters along the path. Find the work done on the object from position x equals 0 to position x equals 2. Hint, there's no product rule for antiderivatives or integrals. We know that. So I'm going to go from 0 to 2 of my force, which is e to the negative x times 1 plus e to the 3x dx. And there's no product rule for integrals, so I can't just apply a product rule. What I have to do is I have to distribute that. This becomes the integral from 0 to 2 of e to the minus x times 1 plus e to the minus x times e to the 3x, this whole thing dx. Now we have exponent rules, which say that if I have a base to a power times a base to a different power, I add them. Think about it like this. X squared times x cubed is, I have 2 x's, and then I have 3 x's. I add them together and I get 5 x's. I have to say this is the integral of e to the minus x plus, and I'm adding the exponents because my bases are the same. I have e to the 2x dx. And now I integrate. I have minus e to the minus x, because omega is minus 1 here. And then I have plus e to the 2x, and we divide it by 2. And we evaluate this between 0 and 2, which equals negative e to the negative 2 plus e to the 4 over 2. That's when I plug in the 2. Minus, and then I have negative e to the 0, which is 1, plus e to the 0, which again is 1, so it's 1/2, which equals, let's see, we have negative e to the negative 2 plus e to the 4th over 2. And this becomes minus 1 plus 1/2 is minus 1/2. Minus minus 1/2 is plus 1/2. That's the final answer. Calculate the definite integral using the fundamental theorem of calculus and also by plotting the integrand and using basic geometry to find the area of the appropriate region. Okay, don't get thrown by this. There's two theorems in the fundamental theorem of calculus. The one we're using in this class is that the same thing we've been using this whole time, which is that I plug in those numbers. The fundamental theorem of calculus that we're using is the integral from 0 to 3. That's really all it means. I'm going to integrate this from 0 to 3 of 6 minus 2x dx. This is really the same as, so this is equal to 6. And this is really like 1 dx. The derivative of what gives you 1? Do you remember? Because we've done it a bunch of times today.
It would be, I'm not sure, I'm sorry.
That's okay. It would just be x, right? What's the derivative of x?
Oh, right, 1.
So sometimes it's helpful to, yes, you could say x to the 0 power. If I say x to the 0 power, which is 1, then it would be x to the 0 plus 1, which is x over 0 plus 1. X over 1 is x. This, you would still use this power rule. I'd say minus 2x squared over 2. These will cancel. And I'm going to find between 0 and 3. That equals 6 times 3 minus 3 squared minus 6 times 0 minus 0 squared. This is 0. I don't have to worry about it. This is 18 minus 9, which is 9. My answer to this is 9. Did they tell me what units I have? It's 9 because I don't know what unit. I don't know if I have meters, feet. I don't know what it is. So 9 is my answer. Now, what it means for B is this is the integrand. So I want to plot that. So let's make a graph. And this is the same as minus 2x. So y equals minus 2x plus 6. Let's plot this. My y-intercept is 6. So there's my y-intercept. And my slope is negative 2, which means I go down 2 and over 1. Down 2 and over 1. When x is 3, I'm going to be at 0. That's my graph of y equals minus 2x plus 6. And now what do I have? I have a triangle. The area of a triangle, remember, I'm always, when I take the integral, I'm finding the area under the curve or here under this line down to the x-axis. If I were to do it with geometry, the area of a triangle is 1/2 base times height. My base is 3. And my height is 6, which is 18 divided by 2, which is 9. They match.